Imagine a source of energy so abundant that it fills every corner of the universe, an invisible force present in the very fabric of space-time. Now imagine being able to tap into it. Unlimited energy, no fuel, no pollution, just pure raw power from nothing. Sounds impossible, right? Well, welcome to the mysterious world of vacuum energy, a strange and mind-bending concept from the frontiers of quantum physics. To understand vacuum energy, we need to first understand something mind-boggling, what physicists call the quantum vacuum. Most of us think of a vacuum as empty space, completely devoid of matter. But in the quantum realm, the vacuum isn't empty at all. It's actually teeming with activity. Imagine this, even in the coldest, most desolate region of space, where there's no light, no particles, no matter of any kind, there's still an underlying quantum field. It hums with fluctuations, tiny bursts of energy that appear and disappear in the blink of an eye. These are known as virtual particles, and while they can't be directly observed, they're real. This phenomenon is known as vacuum energy. It's like the universe is constantly bubbling with potential energy even when it seems like there's nothing at all. At the quantum level, everything is ruled by uncertainty, thanks to Heisenberg's uncertainty principle. This law states that we can never fully know the energy and position of a particle at the same time. So, even in the absence of particles, this uncertainty causes energy to fluctuate in the vacuum, producing those virtual particles we just talked about. The energy associated with these fluctuations is what we call vacuum energy, and although it's fleeting and tiny, it's everywhere, in every cubic centimeter of empty space. Now, this is where it gets even more interesting. If we could somehow harness this vacuum energy, we'd have access to an effectively infinite supply of energy. The implications of this are staggering, but how could that even be possible? One of the few real-world glimpses we get of vacuum energy comes from an experiment known as the Casimir Effect. In the 1940s, Dutch physicist Hendrik Casimir proposed a fascinating idea. If you place two uncharged metal plates extremely close to each other in a vacuum, they would actually experience an attractive force pulling them together. But wait, no external energy is applied to these plates. So, what's going on? It turns out the quantum fluctuations in the vacuum exert a pressure on the plates. But here's the weird part. The space between the plates restricts which fluctuations can exist, while outside, all kinds of fluctuations are possible. The difference in pressure pushes the plates together. This is a direct consequence of the energy inherent in the vacuum itself. While the Casimir effect doesn't provide a way to extract vacuum energy on a usable scale, it proves that vacuum energy is real, and it's interacting with the world around us. Here's the trillion-dollar question. Can we harness this vacuum energy? Theoretically, if we could find a way to control these fluctuations, we might be able to extract usable energy from empty space. But there are a few obstacles. The vacuum energy in any given point of space is tiny, and while the Casimir effect shows that it can influence matter, scaling this up into an energy source that powers cities or even spacecraft is a whole different ballgame. Some scientists believe that harnessing vacuum energy might require new physics, perhaps some breakthrough in quantum field theory, or a deeper understanding of how spacetime itself works. But if we could figure it out, the implications would be enormous. Imagine a world where energy is no longer scarce, where power is drawn directly from the universe's fabric. We could have engines that run indefinitely without fuel, entire cities powered by the infinite quantum energy of space itself. Interstellar travel would be a reality, with spacecraft tapping into vacuum energy to travel vast distances without ever refueling. And that's just the beginning. This kind of technology could revolutionize everything from climate control to space exploration. It could mean the end of fossil fuels, no more harmful emissions, and an age of unlimited energy access for everyone on Earth. But like any powerful force, there are dangers. Some physicists warn that tampering with vacuum energy could have unforeseen consequences. After all, vacuum energy is tied to the very fabric of space-time. What if harnessing it disrupts the delicate balance of the universe? Could it lead to unpredictable fluctuations that cause catastrophic events, like the collapse of local space-time or even worse, triggering a chain reaction across the cosmos? The idea of accessing vacuum energy opens doors to possibilities that are both exhilarating and terrifying. As we venture further into understanding quantum mechanics, we must balance our pursuit of progress with a deep respect for the unknown forces of nature. Right now, vacuum energy remains a mystery, an untapped force waiting in the cosmic shadows. But every day, physicists are getting closer to understanding its secrets. While we may not be able to harness this energy yet, the fact that it exists everywhere, all around us, is a reminder of how little we truly understand about the universe. Who knows? The future could hold the key to unlocking the unlimited energy of space-time itself. And that's the beauty of physics. It shows us that even in nothingness, there's something extraordinary waiting to be discovered. What do you think? Could vacuum energy be the next frontier of unlimited power?